All right, it's chip of the day. We have a SMD Crystal as the chip of the day. It is an ECX53BDU. That's the family. The part that we have is actually a ECS-320-20-30B-DU. It is an old DigiKey part. I bought a bag of them for $5 at the store. You know the store, Anchor Electronics. Yeah, $5. Anyway, I thought it'd be fun for the channel and just for an experience and stuff. At first I thought they were oscillators, but they're just crystals. So the crystal sits in here like this, so pin 1 and pin 3, the crystal goes across there. If you put it in backwards, it's still pin 1 and pin 3, so you can't get it wrong. That kind of confused me. I was looking for a pin 1 designation, but it doesn't really matter which way you put it around. There is printing on the, or stamping on the metal case. So these guys are small. Where's my tweezers? Yeah. These guys are small. Here's one now. So they are, like I said, SMD. They're a metal can on top, and on the bottom they're dark ceramic and little gold contacts. Probably can't see that on camera, can you? Anyway, just tiny. Let's see. While I have it in my tweezers, I have some little PC board adapters, and they seem to fit the pitch of this, so I can put a couple of them along here, and we can just kind of skip a pin. The little pin won't do anything, but yeah, that should work. That should work. All right. Whoa. So let's read the diagram here. So frequency, so this family comes in frequencies between 10 and 50 megahertz. We have the 32 megahertz version. It's a fundamental crystal. It's not a harmonic or a overtone or anything like that. It's the fundamental. So frequency tolerance. So out of the box, at room temperature, they are plus or minus 30 ppm. What is a ppm? That is a parts per million, okay? So we have a 32 megahertz or a 32 million, okay? So if we have 30 ppms, then we have, it could be 30 point, anyway, let's see, let's write it down so I don't get confused, okay? All right, so let's write 32 million. 3, 2, 0, 0, 0, 0, 0, 0. Okay, that's 32 million, and it's plus or minus 30 parts per million, okay? So what is 1/millionth of this, okay? All right, so this is 32 million. If we divide this by 32, that's 1 million, okay? That's 1 million, 32, okay? So if we take this number and divide it by 32, we get 1, okay? So basically, it's plus or minus 1 hertz, okay? So that's what that means, plus or minus 1 hertz, parts per million. Let's see here. It tells you what the load capacitance is. So a lot of circuits will have a something like an inverter, and then you put the crystal across the inverter, okay? And then sometimes you have to have load capacitances, right, to ground to make these things work. Sometimes you need a resistor here. Sometimes you need a resistor in series and stuff. But anyway, these capacitors to ground needs to be somewhere between 8 and 20, all right? And drive level 300, blah, 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 blah. Okay, so let's get one built. All right, here is one that I've already put some parts on. Okay, so we have 3 of them, so we can compare them, see if they're plus or minus 1 hertz or not. So, so we could test this a number of ways, okay? And I might get around to doing this the second way, but today what we're going to do is we're going to use a VNA to test these, okay? A vector network analyzer. So Let me show you. A lot of times people don't use their VNAs in kind of a crude way, but it works just fine. And so I want to show you that today because it comes in super handy and it works great. Okay, I have my VNA, my 8712, and we are going to have these leads. Okay, so this is the 2 ports of the VNA. And what I've done is I've put grabbies at the end. You say, you can't do that. You need to have 50 ohms and, you know, blah, 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 blah. And so this is kind of the cheap and dirty way to use your VNA, and it works just fine. So what we're going to do is we're going to hook the blacks together and the reds together, not to be racist. We are going to go over to our analyzer, and we're going to do a cal response, and we have measure standard, so now we have 0. Okay, so there's our 0. Let's put it in the middle. Scale reference position right there. So that's 0 right now. We've calibrated it. All right, we're sweeping between 30 megahertz and 34 megahertz, so 32 should be right there in the middle. Okay, so we're going to take this and we're going to leave the 2 black wires together, okay? And we're going to take our part and we're going to see here if we can find, let's see, we're going to go between pin 3 and pin, whatever, this one over here. I think that's the right way around, yeah. Okay, so I've just put clip leads on this top crystal over there. And there we go. We're getting some inductance changes through the filter. So it is a filter, right? It's a crystal oscillator, but it's basically a filter. It's going to be resonant at a particular place, and that particular place is right here at 30 megahertz. 32.000 megahertz. So as good as this thing can measure, it is measuring just fine. Now this is the fundamental. There's going to be, the crystal's going to have certain shapes and stuff, and you're going to sometimes get an extra resonance, but this is a big resonance. It's going to oscillate there, okay? So what we're going to do is we are going to save this one. All right, so let's see here, display, data to memory, data and memory to, oops, no, that's divided by itself. Data, oh, there we go, data and memory, okay. Now, when I disconnect the filter, we have something left over, okay? That one, we're gonna remember that one. So we're gonna move down. We're gonna move down to the next crystal. On my breadboard here, there's our next crystal, and it looks absolutely identical. We're getting a little bit, maybe a little more resonance on that second shape where it's resonating. And then let's move down to the last one. See if he looks any different. Now they're very accurate, right? 30 ppm is not very much, and that's the absolute guaranteed. That is not the typical, right? And so yeah, it's really good. All right, so I might do a second video where we actually put this in a resonance circuit and use a frequency counter to see how good they are. All right, so I think the main point of this video is using your VNA with clip leads and stuff. I think I've showed a video before where I use clip leads. Yeah, this is just a fine thing to do. You can actually clip this onto different parts of your PC board and measure the impedance and stuff through the PC board traces and things. You know, don't be afraid, especially at low frequencies, right? Don't be afraid to do this, and even up into the UHF, this technique works just fine. Now, if you start moving up around to gigahertz, then do this. I have one already built here. All right, do this. I made a little SMA, and I put a couple little short pigtails, and then I can solder this onto the PC board, and now I have a short little loop here. and that will work at much higher frequencies if you'd like to do that. Yeah. And here's my little box of parts. So I got quite a few of these little guys for $5. So that was a nice deal. Keep them in my Tic Tac bucks. So that was chip of the day. That number and the real number. The real number of chip of the day was a part number XC1519CT-ND. Yes, sir. That's the number you would order off of DigiKey.